we're talking about dangerous goods transportation regulations, including, of course, lithium batteries. I guess the best place to start would be at the UN level, the United Nations Transportation of Dangerous Goods Subcommittee. So this is a group of regulators from governments around the world, industry, battery manufacturers, packaging manufacturers, aircraft manufacturers. So all getting together twice a year in Geneva, Switzerland for these UN meetings. And so the UN meetings are really, really important because this is often the first spot you'll see proposals put in to change the regulations. So usually the way it works is a proposal will come in to change whatever regulation is being proposed, and kind of the group will debate it, discuss it, and ultimately take action either in favor of adopting the proposed rulemakings or pushing them off to later meetings or just outright denying those proposals. So if you're looking at the reg development side of things, best place to start is at that UN level, because proposals that get adopted at the UN level usually, I guess not always, but usually filter down into the transport modes and into regional regulation. So if you have a lithium battery rule change that gets adopted at the UN level, oftentimes within a year or 2 years, that rule will come into play here in the United States in the hazardous materials regulations themselves. So part of the question is collaboration. You look at a UN body, is usually the first place to start, but there are modal participants as well. If you think about ICAO, so the International Civil Aviation Organization is kind of an arm within that United Nations model, but they would be responsible for the regulations for transport of dangerous goods, including lithium batteries by air. IMDG code, or the IMO, International Maritime Organization, is going to handle transport of dangerous goods by ocean. So those bodies do work together, but if I'm looking at it from the highest level overview, United Nations Dangerous Goods Subcommittee is kind of best place to start, because those regulations, once adopted, get kind of filtered down and spread throughout the world and ultimately become in effect when adopted by country governments and other modal transport agencies. The regulations really dictate a lot of things when it comes to lithium battery packaging, lithium battery design, lithium battery safety. There's an easy example to start with. There's a big difference in the transport regulations between what I would call a small battery and what I would call a high energy battery. So this is the easiest example, is let's just take a lithium ion battery. So in order for a lithium ion battery to be considered small and to be eligible for a lot of exceptions, it would need to have a watt hour rating not more than 100 watt hours, right? So if you look at small batteries, think of them as consumer electronic device size batteries. So a lithium battery that might be in your laptop, might be in your cell phone, probably in your power drill, some power banks themselves. Those are the types of batteries that are considered small. So the reason that this drives product design is if I'm a manufacturer of consumer electronic devices powered by lithium ion batteries, I would be pretty foolish to put a battery in my product that is 101 watt hours, right? Because once you exceed 100 watt hours, you get put into typically the high energy category, where you have additional packaging requirements, you have additional paperwork requirements, you have additional labeling, additional training, oftentimes additional just hazmat fees put in by the carriers themselves. So from a product design perspective, the regulations have this magic cutoff at 100 watt hours, and that dictates a lot of the product design in terms of consumer electronics, and making sure that to the best of your ability, where practical, that you keep your lithium ion batteries to less than 100 watt hours, because it makes them easier to ship and certainly more cost effective. Similar concept with packaging, so DDR packaging is a great example. So when lithium batteries are exposed to some type of damage or have known manufacturer defect, we call those damaged, defective, or recalled batteries. That's that DDR acronym that I just used. So if I want to ship a DDR battery, which, as you can imagine, is one that is more likely to have some type of failure or thermal runaway, there are very strict packaging requirements put into place, specifically here in the United States, around mandating to use either metal, wood, or plastic box or drum, and not having more than one battery per outer packaging, and surrounding it with a bunch of non-combustible, absorbent, non-conductive filler material. So if you're a packaging manufacturer and you want to offer packages for damaged, defective batteries, there's a lot of specific hoops you need to jump through, and those hoops are put into place by the regulators themselves, putting these regulations on the books, requiring more robust heavy-duty packaging, oftentimes some thermal performance materials required as well in terms of the non-combustible filler materials. So Yeah, those are two examples, as far as a watt hour rating cutoff and some of the damage defective packaging. But, at the most basic level, if you have regulators putting rules into place that you need, by law to follow, it's going to absolutely drive how products are designed, how packaging is designed, and how things move across the world. Regulation of lithium batteries, it's a difficult task. So I used to work for DOT, specifically Pipeline Hazmat Safety Administration, and I think sometimes on the industry side, it's easy to think that the regulators have all the answers, they have it all figured out. But in reality, specific to lithium batteries, it's a very difficult thing to regulate because, at least for now, you kind of put lithium batteries from a regulatory side, you put them into two buckets. And are they lithium ion, which means rechargeable, or are they lithium metal, which are the one-time use non-rechargeables? And so those are the two buckets that exist right now. But if you are to take a closer look, what you'll notice is even within a lithium ion category, there are dozens of different lithium ion battery chemistries, and those chemistries have different hazards. So without going too far into it, if you have batteries that are, lithium iron phosphate, so you might have heard the acronym LFP. So those batteries typically, when driven to thermal runaway, are less reactive, less likely to propagate, maybe generate a little less heat than some of the other types of lithium ion batteries like an NMC or lithium cobalt oxide. So if you are a regulator, it's very difficult to get to that level of granularity to say that this exact chemistry needs to be treated this way, this other chemistry needs to be treated that way. So right now we kind of have these two buckets, which even lithium batteries having wildly different hazards will be classified the same under one of the two buckets and have to be shipped the same, even though they pose different hazards. So as far as how do we address this, there's an ongoing project. I believe it got started maybe back in 2017. So what has that been, 8 years or so? And it's a very onerous project, but the high level view is we need to gather as much battery thermal runaway or battery failure test data as we can and start really classifying batteries based on their inherent hazards. So what I mean by that is doing a lot of testing on one type of chemistry. So let's just call the LFPs. So we do propagation and thermal runaway testing on LFPs, and we see that, okay, these batteries don't propagate, they generate heat, but maybe not as much off gas. Whereas if we do the same tests, NMC or lithium cobalt oxide, those batteries are more volatile. So we might have to put them in an entirely new category. So this is, like I said, it's been 8 years in the making. There's still kind of a long way to go. But I think to your question on the evolving regulations, how do we deal with battery safety? I think that's one of the key ways is to start really understanding, get that level of granularity to say that these type of chemistries, these type of batteries are more dangerous than these other types of batteries. Therefore, we need to regulate them differently in terms of, all right, maybe the safer batteries, we don't have to use thermal performance packaging. Maybe we don't have to make everyone get formal training. Whereas for the batteries that are as some of our friends in the battery industry like to say, that are fire-breathing dragons, maybe we do have to put those in special packaging that has some thermal performance capabilities. Maybe we do need more formal training. Maybe we do need, additional packaging restrictions. So that is all kind of under discussion at the UN level. There is a informal working group on classification of lithium cells and batteries that is ongoing and will continue to go on until we have enough data and enough, formal processes, enough regulatory language in place to get adopted. It still seems like it's a few years out at least. I think that's one of the biggest things in the industry right now is this project to really gather battery failure test data and then set the regulations according to what the actual hazards of specific cell chemistries and battery chemistries are.